Today we're going to be doing a head gasket properly. I'll say today, over the next few days, on a Vauxhall Astra J 1.6. Here's the engine. Start by taking the wheel off. Axle stand. Probably seen safer fitments. What we want to do, take the splash guard or arch liner off, airbox off, start taking all your electrical connectors off and throwing them off the back, because that loom will all come off and be able to be swung over to the right. We're going to need to take the exhaust manifold off, the intake manifold off, the engine support on that side off and support the engine from beneath, thermostat or engine coolant flange, rocker cover where the head bolts will be exposed, dismantle the timing and lift the head off. We'll hopefully show you some snippets through the job. Okay, so we've unbolted all the front, taken off all the nuts here, just pried this away safely, giving us enough gap to lift the head. We've taken off the crankshaft pulley, the timing assembly, loosened the tensioner here so that we can just drive it back a bit and take the tension off the belt, whack the belt off. The inlet manifold bolts have all been removed, so the inlet manifold is separate. Around this side, the coolant flange with the thermostat has been removed. So just to show you what we've done, there is a small earth cable here, this small earth cable that goes onto this back connection around here. There's the wiring loom that plugs into all of the injectors, runs round through and round the back here to the throttle body and stuff. We've unplugged the loom and slung it all the way over to the side. As I say, we pulled that forward, we've dismantled the timing. This has 1, 2, 3, 4, 5, 6 Torx bolts holding the inlet manifold on. They've all been removed, the injectors are still in play. We've just taken the necessary bracket off of the side here so that we've got enough place to get through. We're taking this coolant pipe that goes to the throttle body out completely because it's quite brittle and fragile and will be in the way. And now all we need to do is remove the header bolts that hold the head down, and then we'll be able to crack the head free of the block and raise it up. Right guys, we're back on this engine job. The head's been prepared, the gasket we were waiting delivery for, so we're going to prep. Now normally in the water jackets and oil galleries I will try to suck out things like this because I don't want any fight for my bolts or any fights and pressure build up, because these are full up to the rafters. I'll also clean the surface, clean the heads of the pistons and get the area prepared for the new head. Key here is all these grey gasket remnants which are going to create high spots around all the sealing areas, which there's tons of them, need to be perfectly clean. We need to dry out the cylinders and we'll show you what it looks like straight afterwards. Okay, so compare that to the clip from earlier. We can see all the grey's gone, we're nice and clean. Importantly, you can just see the colour difference between the inner ring and the outer ring here. It's like a kind of a brassy colour. Before that was black if you look at the video because of the carbon build-up from the combustion within the chamber. You want to get that ring of carbon off so you've got a nice flat seat all the way round. So we're now going to degrease this with a degreaser so that there's no oily substance left, and we're going to be ready to go after I've drained out these ports here, because where the bolts go in to hold the head, they have to be torqued to a certain Newton meters, which is measured by a gauge. Now if my bolt is fighting fluid fill up in a hole, it's obviously going to make it feel tighter and tell my wrench that I've reached the correct tightness when I haven't. One of the most important things, as I say, is to drain out all bolt holes and to ensure that the fluid reservoirs as well as the galleries for the oil aren't topped up to the max, so that when you're putting the head down and torquing it up again, it creates a pressure against the head, which creates a pressure against the bolt, which will wrongly tell me that I've reached the correct tightening torque. So we've got to get that right. The preparation is key. Prep it twice if you have to, and do it once rather than doing it twice and costing yourself a lot of money and time. Here's the brand new multi-layered steel head gasket made of multi-layers of steel. On comes the head. So guys, the cylinder head is back on the block with the gasket between it. No bolts in there. There's a fresh box of stretch bolts. Here are some that we removed earlier. Don't know if we're going to see a stretch in this, but if you're interested to know, so let's have a look. Take an old bolt, take a new bolt, well, there you go. You're going to be able to see the stretch, guys. So here's your bolts. The new one is the black one, the shitty oily one is the old one. And when I put them together, pull the washers right up and touch them end to end, you will see at this end, when the washer's moved, there's a fraction of a gap. Now that is probably 2 mil, maybe a touch more, but that's enough to make the head not tight enough and mate with the surface. Right guys, so this is the head gasket packaging, L-ring. This is the advised to torque tightenings and sequence. There are 5 passes, and I'll explain exactly how that works. Here's our bolts in the head. They match up with the pattern here. I've double checked this with the data on our system on the computer to ensure that they all tally up, and they do. So we'll be tightening in this order: this one first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. And we will do first of all 25 Newton meters, all of these in that order. And on the second pass, 90 degrees, third pass 90 degrees, fourth pass 90 degrees, and finally the fifth pass at 45 degrees. We'll be using a torque wrench to get the Newton meters in torque, and then we'll be using a different gauge to get our 90 degree turns and 45 degree turns. Again, each pass needs to be done in this sequence, and you need to leave a little break in between for things to relax, or you could cause things to crack. So it needs to be done very carefully. We're going to get that done now, and hopefully the head will be seated. Now you do get great big torque wrenches in a 1/2 inch with a great big bar on it, but for 25 Newton meters I don't need it. I could do it with a 1/4 drive, but this is a 3/8 drive torque wrench. It's been set at 25 Newton meters, and so we're going to tighten it up now. So as you know, the torque wrench is set on 25 Newton meters for the first pass. Be careful to make sure that you're doing it in Newton meters, not foot pounds or any other metric. Doing number 1 first. All we want to do is tighten the nut, bolt rather, till I hear that click. Just show you again on this one here, on bolt number 2. There you go, the click tells me it's done. No further than that. Simple. How to use a nice mechanical torque wrench. There are digital varieties out on the market, but I'm quite happy with a mechanical bit of kit. Once I've worked my way through the first pass, we'll give it a rest, and then we'll move on to the second pass. Now I don't usually use an extension when torquing, because the extension, the longer it is, the rod actually micro twists as you're tightening, and it takes up some of the Newton meterage, or sometimes some of the degree that you're turning. So I'm going to see if I can do it without the extension on this particular job, to do the second pass now of 90 degrees. Guys, here we are about to put the timing assembly back together. You'll see I've put this plate in the back here to line up the camshafts. I've also lined up the crank at the bottom there, which you should see. It's not lined up now, but it will be in a moment, where this mark needs to be in line with this mark here. So we'll be there in just a moment. But first and foremost, one of the things I want to get in now is not to forget to put your rear timing cover back onto the car before you put all your sprockets and bits on. So we're just going to put the timing covers on, and then we'll get onto the timing and explain that with these special tools shortly. Okay, now our cover's all on. We're going to give that a wipe in a moment, and then we're going to stick our sprockets on. These have got the sleeves. Remember, one's an exhaust and one's an intake. The sleeve goes to go into each of these holes. Pop your sprockets in, and then we'll move on to the tensioner shortly. Right, once you've got your sprockets on hand tight, you'll see, sorry about the Tipex mark, someone's marked it before, but this little nodule here, located here, and on this side, you have to look very carefully, but on that sprocket tooth, there's a little dot indentation just above my blue glove finger there. Those two need to be lining up with each other straight. This dot will appear ever so slightly higher, and what you have, I'm probably going to struggle doing this with one hand, but you have a tool, and if you look carefully, there is you have to look really carefully, a line just above the part I'm holding, just there at the back. That line should line up with your dot. You've got to put the intake side in first, because the pulley has it's going to be very difficult doing this one-handed, but essentially what happens is this goes on one side, the other one goes on the other side, and the line across the middle should be nice and straight with your dots on both sides. I'm just going to get it all set up because I've got only one hand, and then we'll take another vid. I've got a free hand for a minute. As you can see, I did say it would be ever so slightly higher, but that dot lines up with that, And now what we're going to do is, again, I'll have to stop the video, but this portion slots in on both sides to lock in here, and we'll line up this part of the locator. So let's have a look. There we have it, the tool's in, line marked on that side, line marked on that side, perfectly lined up. My tools are a little bit Mickey Mouse, they're plastic, they weren't a perfect fit, but they are located in the correct place. So now the tensioner is next. I'm going to do that rather than stopping the video, just show you what I mean. So on the back of your tensioner you will have this little lug hanging out the side that needs to go into its locator here, locator hole, before you tighten it up. So just do that. This needs to be tightened to 20 Newton meters, and then we'll move to the next video. Sorry about the rain, we will be drying it off obviously, but just a final check just to show you there. We've got the little dot, the line. I did say this would be slightly above earlier. You've got the line on this side, hopefully you can make it out, matching up. Ignore the Tipex someone's put on there. I'm more trying to focus, but it's not. That there's a little divot just behind it, so that's all marked up. All the slack is off the belt. There was no slack. The slack should have been on this side, which should have been taken up, and you might have had a fraction up here, but as soon as the tension is released, that will take up the slack. And obviously down the bottom there, your crankshaft timing mark needs to also line up just like that. So we're good to go. So now we can take the locking tools out and put everything back together. Turn the engine twice to confirm all our markings have lined up. We're happy with that. So we're now putting the timing covers back, the rocker covers, engine mount, drive belt situation, throttle body, etc., and we're ready to go. Here the car's started, there's no warning lights, we've got the temperature up to 90, the heating's wonderful. I haven't yet flushed the cooling system, I just want it to circulate, and we're all good.